All right, we're back. We are on page 3 of notes 3 of Calc AB, so that kind of rhymes. And we've already done the first part of it, and we're going to do the second problem on the page. So just to review what we're doing, we are answering these things. So we want to describe the particle's motion, meaning like left and speed increasing, left and speed decreasing, right, left, right, speed increasing, speed decreasing. That's what we want to say. Create a graph of the particle's motion. So that's interesting. It's like a little different from position over time. It's the actual motion that we're trying to show. And they kind of like make these little snake-ish kind of figures. We want to find the displacement, which is probably going to be the easiest thing that we do. And then the distance traveled, which will probably be the worst thing that we do. So let's get started. Let's see how this goes. All right, so to do this, I know that I'm going to need S is the function. I need S prime and S double prime because S prime is velocity. So I'm going to start by saying that V of t equals S prime of t. I don't know if I did that last time. I don't remember doing the last problem like at all. Oh, look at me. I did. Nice. Nice work. That's it. You gotta get that memory down, muscle memory sort of, but in your brain, so really just memories. The derivative here, so 1/2 minus the derivative of natural log is 1 over the thing times the derivative of the thing. So that's our velocity. That's not great. So the velocity doesn't exist at -1. Doesn't matter because we're stuck between 0 and 3. So velocity exists everywhere. Let's find the acceleration. So a of t, which is going to be v prime of t. And you could, if you wanted to, say it's s double prime of t, because it is, but that seems like overkill. So in my mind, I'm thinking of this at the derivative of 1/2 is 0. I'm thinking of it as -1 quantity t plus 1 to the negative first. I'm going to bring down the exponent. That'll be -1 times -1, so positive. And then t plus 1 to the negative second, because I'm subtracting 1. So I'm just going to write it as 1 over t plus 1 squared. And again, so that's not defined at -1. It doesn't really matter because -1's not in the interval we're looking at, which is actually only from 0 to 3. So we need to figure out when this thing turns around, right? So I need to know when v of t equals 0. So v of t equals 0 would mean that 1 over t plus 1 equals 1/2. So the only time that's going to happen is at t equals 1. You don't really need to do any math to get, well, I mean, I guess you're always doing math when you solve that, but, I'm not going to algebraically solve that when you can just look at it and be like, you need t to equal 1. So that's going to happen. And then the acceleration is actually always positive on our interval. It's actually always positive. So a of t is greater than 0 for 0. And that's going to make our describing the motion a little bit easier, I think, because there aren't going to be as many changes, I guess. Actually, in general, this is it. Well, I don't want to do it. I don't want to jinx myself and say like this seems like it'll be easier to do. So what is the first step that we need to do? So last time I made a table, I'm going to describe the particle's motion. Okay, so to describe the motion, I need to do some stacked sine charts. So I don't really need one for a of t because I know that a of t is positive. So 0 and 3, and then a of t, there are no zeros, so I'm just going to go 0 to 3. And then I know it's always positive because I'm squaring, so positive. Okay, so now I need to sub into the velocity. So if I sub in something that is basically 0, right? Basically subbing in 0 here. Well, then I'm doing essentially 1/2 minus basically 1, which is going to be negative. So this is negative. The other thing to keep in mind is like the 3 that's there is just there arbitrarily because our interval is from 0 to 3. 3 is not a critical point, so it's not like the derivative is going to change sign there. So the sign that we get from 1 to 3 is the same as the sign that we're going to get out at like a billion or a trillion. And that's basically going to be positive 1/2 if we're out at a billion. So this is going to be positive. Or you could live dangerously, plug in 2, and then work it out, and you'll still see that it's positive. But I think that thinking in the extreme case is a great idea because it makes it a little easier to work out what's happening. and keeping in mind when something is on your sine chart because it's a critical point or a point not in the domain versus when it's just arbitrarily assigned by the problem can really help you fill in these charts. So we got our velocity, we got our acceleration. So let's say what's happening. So this will be, I guess, number 1. So for 0 less than, we could say less than or equal to t less than 1, we are moving, that there's no way that says moving. I don't know what that, it says like moving left. And I know we're moving left because the velocity is negative, but I like to save that until the end. I don't know why. And speed is decreasing. And now we got to say why. So because v of t is less than 0 and a of t is greater than 0. So to review, speed will be decreasing anytime acceleration and velocity have opposite signs. I don't think in my life I've ever said acceleration and velocity until there. It's when velocity and acceleration have opposite signs. So that's why speed is decreasing. Moving to the left because velocity is negative, and by convention, we say we're moving to the left when velocity is negative. So far, so good. For 1, 2, 3, you're going to be moving. Oh my God, I did it again. I just don't know how to write moving, I think, is the real problem. Let's make it go away. Moving right. So this time, velocity and acceleration have the same sign. So speed increasing. So why would that be? That would be because v of t is greater than 0 and a of t is greater than 0. Okay, so far pretty good, I think. So I think for this function in particular, having our stacked number lines here is going to help us a ton when it comes to deciding what's bigger, which of the positions are bigger than the others. And you will see why, like right now, because what I'm going to do now is I'm going to create a graph of the particle's motion. And to do that, I need to know where the particle is at these key times. So the key times are 0, 1, and 3. 0 and 3 because they're endpoints, 1 because it's a critical point. So let's see if we can do this. Okay, for a second there, my brain was like, 1 is not a critical point, but it is. Okay, so there we go. So I'm going to say t and then s of t. So I need 0, 1, and 3. All right, so I usually, like when I have to do work for these, instead of doing it in the s of t column, I always do it like a little to the right of the column, which in some ways is kind of weird. But at 0, you get 1/4, let me make this bigger, 1/4 of 0 plus, nope, minus natural log of 1, but the natural log of 1 is 0, so you just get 0. Here you get 1/4 times 1 squared minus the natural log of 2, which is, 1/4 minus the natural log of 2. So what is that? Do we even know what that is? So natural log of 2 is like 0.69, so this is like 0.25 minus 0.69. It's a negative, which maybe is useful to know, but maybe also is not. No, it's very useful to know because we need to know how to put these on the sine chart, on the number line. But I'm going to explain that in a second because I think that velocity graph, the sine chart rather, is very helpful here. And then 3, it's going to be 1/4. Is it really 1/4? Yeah. 3 squared minus the natural log of, 3 plus 1, so 4. Okay, and that's, I don't know, that's 9/4 minus the natural log of 4. Okay, so I kind of need to know the relationship between 1/4 minus natural log of 2 and 9/4 minus the natural log of 4. And that might be difficult to work out, except look what we have up here. So we know that the particle is moving to the left from 0 to 1. And then after that, it's going to move to the right forever. So the real question is, does it get back past 0, I guess? So I do need to work that out if I'm going to have an accurate graph. So do I know? So this is basically 2.25 minus, so the natural log of 4 is the natural log of 2 squared, which is 2 times the natural log of 2, minus 2 times the natural log of 2. Natural log of 2 is like 0.69, so 2 of those is definitely smaller than 2.25, so that's positive. So this is greater than 0. And then 1/4 minus natural log of 2, we actually just know is less than 0 because we know that between 0 and 1, the thing is moving to the left. So it's got to be less. All right, let's make our motion graph here. So our number line is going to look bizarre. So so this is the answer to number 2, or this is our attempt at an answer to number 2. I'm going to put 0 like in the middle where it almost certainly doesn't go. And then here, 1/4 minus the natural log of 2. And then here, 9/4 minus the natural log of 4. So that's weird. All right, and then we know that we start at 0. So this will be at t equals 0. And then we go to the left. So this happens at t equals 1. And then we keep going. This is at t equals 3. So we can fill in this. This is just generally a long process. I mean, there's really nothing you can do to shorten it other than not explain every single step and talk forever. Other than that, though, what are you going to do? All right, so that's number 2. Number 3, what we got to do, particles displacement. Displacement is going to be the easiest thing that we find, right? So displacement is the difference between where you started and where you stopped. So on this little thing here, our displacement is actually this, right? That's how far you are from where you started, and you're further to the right. So it's just going to be our displacement, which I guess you could say is like your delta S or something. Like I don't really have a good notation that I like to use for it. So I usually just write displacement is going to, in this case, be S of 3, where we end up, minus S of 0. Displacement is a very Algebra 1 concept. You could have done it in Algebra 1. No questions asked. Definitely. Well, I mean, you probably would have had questions, but you could have done it. So we get just that, minus 0, but I'm not going to write that. So this is our displacement. That's how far we are from where we started, and it's a positive number, which means we're to the right of where we started. Distance traveled. All right, so distance traveled, technically, what we want to do is the absolute value of S of 1 minus S of 0 plus the absolute value of S of 3 minus S of 1. Now, since we have the picture, we know that the absolute value of S of 1 minus S of 0 is actually going to be S of 0 minus S of 1, because S of 0 is bigger, right? So this is really, let me use a different color. So the first one, we're actually just going to go S of 0 minus S of 1. So that's going to give me 0 minus, so this is 0 minus the quantity 1/4 minus the natural log of 2. So that's nuts. Plus, so, and that's right take away left. Whenever you're finding a distance, it's going to be right take away left. Or top take away bottom. One of those. That'll give you a positive. And then S of 3 is way bigger than S of 1. So this will be S of 3, which is this, minus S of 1, which is 1/4 minus natural log of 2. Okay, well, that'll be plus though, because let me put that in parentheses, right? So it's S of 3 minus S of 1. I almost didn't put parentheses, tragedy. Okay, so let's see. This is, what do we have going on? I feel like we have stuff happening here. I'm getting negative 1/4 plus natural log of 2 plus natural log of 4 minus natural log of 4. Did I say 9/4 wrong? I don't, in my head, like, or maybe I said 9/4. I feel like I said natural log of 4, which doesn't make any sense. Minus a 1/4, and then plus a natural log of 2. Okay, so what happened? We end up with 9/4 minus 1/4 is 8/4, minus 1/4 is 7/4. I never use equal signs. It's really one of my flaws. 7/4. Then we have, this is kind of interesting. We have plus 2 natural log of 2, and then we have natural log of 4, but natural log of 4 is 2 natural log of 2. So I think maybe we just get 7/4 for our total distance traveled. There's no natural logs potentially in our distance traveled. So that's it for our answer. So I'm gonna go to the calculator and just confirm or refute. And if I have to refute it, I'm gonna want to cry, but that's okay. You know, sometimes you need a good cry. Let's see how this goes. 1/4 t squared, and then minus the natural log of t plus 1. Okay, so you know, we could do the whole thing. Solve derivative s of t with respect to t equals 0 for t. And we get -2, but we don't care about -2 because we're only between 0 and 3. So what do I want to do here? Displacement. I need to do s of 3 minus s of 0, which gives me 9/4 minus 2 natural log of 2. We put 9/4 minus the natural log of 4. That's fine because the natural log of 4 is the natural log of 2 squared, and then exponents become coefficients. Properties of logs comes up a lot. Then I wanted to do the absolute value of s of 1. You have a template for absolute value, by the way. It's in like in the templates. Mine's on row 1. Where did everything go? Oh no. I hope it comes back because this video. Okay. So it's in the templates. I never should have done this, and now it's like stuck there. Great. I'm just gonna go over it. Hope that this is still working. Who even knows? Plus the absolute value of s of 3 minus s of 0. No, s of 1. Exactly 7/4. So it worked. That's kind of amazing. So sometimes I can get rid of this by pressing menu. Yeah, that worked. Okay. So we got the answers. I'm going to try to go back to the notes. Probably not going to work. Hopefully the video picks everything up and I don't have to do this again because I really don't want to. It's not looking good for getting back to the notes, but I'm going to try. It's not working at all. So I'm just going to end the video here. I'll be back in the next video to do more. So hopefully I'll see you there.